let's go for it. Yeah. So we keep working on the stuff. Oops. Sorry. Trying to figure out the lighting better, not better. I don't know. We'll see. That bothers me a little bit. Anyway. Okay. So we stick with the roadmap. We really stick with the roadmap. The point is, I and I think I've already I'm a bit like going in circles here, but I'm like, every time I realize I have a bit of a more deeper conversation with myself, I realize that essentially it's kind of a hobby in a way, right? Kind of exploring the whole quantum mechanics from scratch and kind of trying to understand, how the world works and all these kind of things, and and learn a lot along the way, and kind of sharing sort of the most raw version of these with the world, with the YouTube channel makes sense, and something that I want to keep doing. It's something that I don't want to get on the way, or I don't want any kind of at the end of the day, it's like what is it that I'm looking for, right? I'm looking for, on one end, I realize that I kind of have to keep separate, the hobby itself from whatever I want to be doing, right? Like if I'm let's say I want to build, like, for example, this, another income stream or something like that, right? I should stop trying to monetize this kind of stuff, and I should just be more like, this is the pure hobby in its purest form. It's the exploration. It's just curiosity, and so keep these two things separate, because otherwise we're gonna get nuts. I don't want this to get in the way of what I'm really enjoy doing, right? And I have the luxury that I can do that. So having said that, we will take on where we left last time, which was basically I was struggling with, because I remember that we're trying to solve these, but we're trying to do this with Simpai, right? So, and I was having issues with the very first thing, the very simple thing of compute the normalization factor n. So a free particle is initially at t0 and a state that described by this way, this wave function. And so we just want to compute the normalization factor, which here they tell me this is the answer. And then if I go and I what were we doing here? So, well, I almost forgot all the stuff. I'm defining n, and I know that n must be n doesn't have to be real, right? So we don't really know that. Alpha is a real parameter. We know alpha is real, so this for sure. And then R is going to be real as well, because R is maybe that is in essence the problem. Maybe this is there's something off in terms of how these R is defined. Because I don't know really what R is. Should I treat it as a constant? Is R like X? Because X is bold, and this means it's an array, and I think R is just the distance. I think it's just the distance. It's the radius, right? It's just the distance. God, so much to, like, I literally was gone. I literally was like a month ago, basically, started working on this all smart contract stuff, and crazy. What is R? Maybe let's I don't know. Let's see. So normalization factor n. Normalization factor quantum mechanics exercises. Is this another one? That's another. It's another book, maybe. Example shit. No, it's the same book. Normalization in page 3. Oh, this is actually like a nice kind of cheat sheet. Write down the normalization condition for the wave function if it is necessary to interpret its product density. Wave packet, commutator. I want some exercise, some example. This video. This video has some. Oh, let's see, exercise. So this is unnormalized. Let's try like that. I mean, that's kind of rather simple, right? But it's like sinus of 2 pi times x, and so this is in theory the solution of this being normalized. Just let's just do normalization test dot pi, and so what are we gonna do? I'm basically gonna copy the same, but I'm gonna say I mean, we don't have any symbol. Now what do we have? We have just x, right? To be honest, just the symbol x, which I don't know if you can say the real. I think that it might be one challenge that I'm having. And so the function is basically, oh no, we do have n. That's what we're trying to solve for. So I'm not gonna kind of assume anything about it, and I'm just gonna say the expression is basically times sinus 2 times how to say what's pi in SymPy? Pi in SymPy. Should I just use pi? The documentation is funny, huh? Just write pi. How is it gonna work? Times x. And so I get the conjugate, and then yeah, let's see what happens. So I don't have to run. What I have to do is I have to do Python, right? X not defined. That's because it's these. Not defined. What am I doing? What I was doing here, so integrate with respect to R. No. Integrate. Can I just not integrate? I think I can just do the indefinite integrate like this. Do I have to specify integrate? I forgot a lot, man. Integrals, because I have to specify, yeah, I have to specify what am I solving for, right? Or integrating for x. I think so. Okay, something. It's funny because integral with respect to x. And if I say this is real, then a 1. You see, I must be doing something wrong, because if I can't even get this one, if I can't even get these, what am I doing wrong? So I have these, then I conjugate it. So what is n, right?
And you can see it's somewhat higher for the normalized one. And if you go ahead and evaluate the integral of psi star psi over the entire length of the box, if you do it for the red unnormalized curve, you'll
0,
find
1.
that it sums.
Maybe because of the bounds, you know, my friend. Maybe because of the bounds. Maybe I do have to. Maybe I do have to say 0, 1. There we go. Yeah, look at this. Okay, so the bounds are important. So if I don't say it's real, get the same. Okay, so at least that at least that works in a way. The problem I have here is so I have n, okay, I have a alpha we know it's real, and then we've got r, which is kind of, I'd say, the x thing, right? So expression minus something. Ugh. It's a real parameter. Yeah, maybe that's the thing, is I have to find. I feel like I don't really know what the bounds really are. How do you go about, what is it that I'm doing wrong? So this is, let's say, x2. What am I doing? This is too complicated. Zero 5. If I don't specify that, then I get something even more complicated, I guess. No. something is, oh, that's just, it's these two lines. Because the problem is there's an R in here. My something tells me that I'm missing something at the very sort of deepest level of like interpretation, just to know what this R here is. So you know what I mean, like I feel I'm just, that's not, that's what bothers me, is that it's this X in here and there's an R. And so I know, as a matter of fact, because of what Guillaume told me in Twitter, that it's a quantum mechanics notation bold letters, that these are arrays or something like that. Bold font, small font for operators. Yep, I'm just so quantum mechanics, wave function, X and R, the R observable. If R is good luck finding anything here. That is the single most annoying thing ever, to understand what is going on with these. And I can't even figure out a way to search for that efficiently. Because yeah, I think because R expectation value of R increases with time, and here we're mixing up funky stuff, meaning everything, R's and X's and X in bold letters, operators, quantum mechanics, operators in bold. This is what I just don't understand. I just really don't understand. If I, let's say, if I just plug in the solution, where am I? If I would just plug in the solution, right? Just make this dummy. Alpha is a real number. The problem is that I can't figure out how can that even be just a 1 if we've got an exponential function. And again, I think I did that one, so let me just try to find this again. I think there was a math, I think it's Desmos or something. Desmos graph Rechner, graphing calculator. And if I, yeah, it even remembers that. So if I do something like, let's say, we'll have to give it some numbers, I guess. Let's say alpha is 1, okay? So it's 1, it's 1 divided by, so it's 1 divided by what? Pi, no, pi goes here, and here is like a 3 divided by 2, yeah, correct, and then it's times e, and then a minus x, right? And so now we say times e to the power of minus, and now we do x. You see, that's the problem, right? That for some reason these is like, how is this even supposed to be 1? Okay, we know if it's x, we know that if it's radius, we know that it's bounded below on 0, right? If you do 0 to infinity, it could make sense because it's r, so we're kind of cutting off, you know what I mean? How can I want to calculate the integral of these. Let's see if I can calculate the integral of these between 0 and infinite, right? So if I say, I'll go back here. So this is just as a playground, right? Or we can just do it here as a playground. So I'll just say test integral. So this is basically, what did I do? I do 1 divided by pi, and then it's what is it? It's 3 divided by 2. So this whole thing times an exponential of minus 1 times x, and then I say and then I basically say print integrate tint on x 0 infinite. I think you do it like that. Yeah. Let's see. And can we comment all these? Yeah. And we run this, see what happens. Fair enough, x is not defined. We'll define it as a real number. Okay. What if, can I just define alpha and then just call these a? Can I integrate like that? Does this make any difference? Oh, sorry, because then if I do that, then I have to adapt it to be like that, because that's what the solution says, correct? That's fucking shit. It's 3 over 2, yeah. God, oh my god, man. That is not even like... So... 2, like if I give these things values, this is not, that's what's telling me, like, that's what's telling me that there's something off with this, because I'm defining, this is then something wrong. Like even if I just check the solution, right? I'm just literally checking that solution, and it's not giving me these. So I must be doing something wrong with these. Like free particle. Let's start there. So free particle wave function. Mathematical description. Okay, so here we're having something a bit more interesting. You have this form, right? But at least there's this stuff here, right? At least there's an R, and then it's everything defined in terms of R. I think this is just another notational. Like I must be doing something wrong with these. This is the problem. I just don't understand how is that defined. So I think I'm gonna have to ask Twitter again. I think I'm gonna have to ask the Twitter brain again. God, how do we even phrase that though? Twitter.com. So for the quantum mechanics, for the quantum mechanics pros out there, I'm stuck with something that feels like notational misunderstanding on my end. So basically I feel like R is some sort of radius, or or something that's a real number, but I kind of like but I kind of don't see with the bold X, which I know thanks to to be honest, it's thanks to Guillaume, thanks to Quantum Vert, that means it's got multiple dimensions to it, right? Which I know it means, I'm not sure if that's what he said, so which I know it means has multiple dimensions, perhaps this one is it. But no matter how much I try to normalize these, it just doesn't yeah, I don't know, it does not really I don't know. I'm not gonna step into these. Let's see if there's anything that clarifies in terms of, you know, there's something I feel the understanding on my end. I feel R is sensitive varieties or something that's a real number, but I kind of don't see a connection with the bald X, which I know it means it has multiple dimensions. I'm trying to normalize these to normalization constant n, but should I just treat R as the thing I'm in? Yeah, I don't know, to be honest. What is the question that I'm trying to ask? So with some it feels since time my end, I feel R is some sort of radius or something that's a real number, but I kind of don't see the connection with the bald X, which I know it means it has multiple dimensions, perhaps. Why would one write things like these though? Like, is the relationship between X and R assumed? I don't know if that's really my question, but let's see. So I feel R is some sort of radius or something that's a real number, but I kind of don't see the connection with bald X, which I know it means it has multiple dimensions. So I said, why would one write things like these though? Is the relationship between X and R assumed, as in like assumed as and like a default coordinate center or something? Yeah, it's because that seems to, I mean, I got the method, it just seems to work well. I just didn't know. The problem is I almost feel like I'm just gonna get stuck with the rest of the exercise because of that. I know I've already been exploring this stuff with the momentum, which is going to be my next challenge, I guess. Spatial probability R squared. Yeah, it's definitely going to be modify the initial wave function, assuming initially the particle is in a state described by these. And now it gets more factile because now we're missing out R and X in here. Awesome. This just doesn't make sense. Maybe let me take a look at another exercise. Maybe there is what the hell? A free particle is initially at t0 in a state corresponding to the wave function. So now it's wave function with respect to R. Awesome. Which I don't know if it's in bold. And then I calculate the probability density of finding the particle with momentum at any time. Is it isotropic? What is that? Nobody knows. Can I find the proof of normalization? No. I want problems. So I want the problem free particle normalization factor. Can I just okay, so here there's something else, and here is considered a free particle moving in one dimension. So here we're told it's one dimension, that's why X is not bold anymore. Okay, so here there's the okay, so there's a funkier thing. X plus x0, x minus x0. What is x0? Okay, so there are known real parameters. Okay. I mean, can I try? Let's see. Let me try to do that. That seems simpler because it's one dimension and there's no funky stuff in here. Let's just try to do this one, and we can probably call it a session again today. So let's try this one. So we have, what do we have for this one? So this is basically, can I just copy that? No, can I just duplicate? And this is going to be exercise what? Exercise 2.6. So rename 2.6. And so we have here what do we have? We have A, so alpha and x and x0. So alpha x, it's one dimension, so we know that x actually must be real as well. No? x0. Can I do it like that? I think so. And so we have n e, and then it's minus alpha x plus x0. Okay, so you know, I might as well just do that. It's so I don't have to. Okay, so we know it's n times the exponential of, and now we have minus a times, then we have x minus x0, and this is basically squared, and this whole thing, I'm just a bit freaking out with the parentheses right now, I know, but this thing is divided by 2, okay? Yeah. And so then we have the same thing plus, and then we have alpha x, and then, so, okay, sorry, this is plus, this is minus squared divided by 2. So we have this thing. We know we have n, we know a is real, we know x0 is real. We don't know x in theory. It's one dimension, so it should be real. Maybe that makes it easier. And then let's just see. This is the, what does this do? R is not defined. Sorry, we're integrating with respect to x. It's taking a while. But that seems to be, and the went-away function. Okay, this take a while. Probably. Let's see. Because this is just a straightforward thing. For respect to y, with respect to x, integrate. But I can't. Maybe I should again give it. Should give it some limits maybe. Because yes and no, right? Because here's x, so x can be really anything in one dimension. Unless for some reason I know that, I don't know, if I do these plus these, like, what do I get? I get a funky thing like that. So you know, -3 squared -3 squared, and then I take a look at these divided by 2. Let's assume that I do something like these, and this is, I don't know, 1. So what is the shape of this if I do? Okay, so actually that looks like that. Yeah, but I mean, and what? And what? Oh, look at this. It's finished the integral, and now we're trying to solve for n. Oh my god. What the hell? What do we have in here? So we have that the factor is I mean, it does look fairly complicated, but square root of and some funky integrals and stuff like that. Oh god, that's definitely not what I'm looking for, obviously. If I would add some bounds to these, and I'd say -10, 10, for example, would that help somehow? Would that make that easier? Have I done this correctly? Yeah. The thing is, I kind of feel like the trick with these is that there is something maybe that I'm missing about the shape of these, or something that allows me to simplify something, whatever. But I just, like, the thing is, the brute force approach should just work, right? I mean, if I just put SymPy to work on it, why isn't it that I'm getting the correct answer? Alpha and x0 are known real parameters. Okay. So minus, and x plus x0, x minus x0. Still takes a long time. Maybe just, again, I should assume that this is a real number. I don't know. If I do so, does it make it easier? I'm so stuck with this, man, that I don't know. Let's see if it gets it faster. If not, I mean, I'm stopping here anyway. Happy to be back at these. I think if not, I'll just move on and kind of try to come back to these later. I need some fresh air. because I definitely feel that's the correct approach to these. I mean, you know, it's worked with this example. Man, but I don't know. For some reason, maybe the answer I'm getting is in a way correct. I just have to simplify it. I don't know. Integrate. I don't know if the integration simplifies. Maybe it's just a matter of simplifying. Maybe. SimPy. Simplify results from integrate. Simplification. Okay, maybe I should just simplify. It's taking too much. Anyway, I'll go ahead do other stuff and then come back to this at some point. I will move on to the. I'll move on to the second point, which is basically the probability density of the momentum, right? And you can see I was already researching in terms of, I know the way that you go from one base to another is the integration, and I was trying to understand that from an intuitive perspective, which I don't think I've wrapped my head around yet fully. But that's kind of what it looks like here, right? So there's some sort of, okay, they still just go with n though, but there's like some sort of, oh, that's maybe later, I don't know. It's some sort of integration that's going on here, whatever that actually means. What does that mean? Is that something I can, what is that? Proportion? It's proportional. God. Oh, it finished. But essentially that doesn't look good. Sorry, it doesn't look good. Anyway, see you next time.